So, module number, I believe this is module number 5. Yes, module number 5. So in module number 5, we're going to talk about security services. In fact, in this module, which consists of, let me see how many lessons we have in this. 5 different lessons in this. Actually, 4 different lessons in this module. So we should be able to get through this one over the next couple of hours. But this is the Designing Security Services module, right? We know that because of the robustness of the internet, robustness of the networks today, security threats in today's network are kind of wide and varied, right? And security is really one of the most important points when we're designing our networks, okay? So when it comes to the CCDP, obviously we would be remiss if we didn't talk about certain aspects of security in this concept, right? Enterprises tend to secure their resources, but there's a trade-off between securing those resources and then affecting business operations or functionality or just mobility and flexibility in the business itself. All right? Security is always done in a defense in-depth approach, meaning that we secure all levels and all layers of the network. So in this module, we're going to talk about how to deploy security services, what different types of solutions are available today, and how we would implement those network level security solutions throughout the network. So we'll talk about kind of give you guys an overview of security services and how they apply to the enterprise. We'll take a look at designing infrastructure protection. That's one of the lessons that we'll actually go through. Another lesson is looking at firewall and IPS solutions. And again, this is not hands-on. We're not necessarily looking at this from the perspective of how we would configure a firewall or how we configure these particular services, but we do want to take a look at the overall solutions and maybe kind of how they fit into the network design. And then finally, we'll look at our network access control solutions, things like 802.1x and the identity services engine and so on. So again, some stuff that you guys are probably already familiar with, but let's tie it all together from a design perspective. In lesson number 1, we're just going to talk about what Cisco's approach is to defining security in a modern enterprise network. We know that security is really one of the most important aspects in any modern network design. We have to protect our critical resources. We have to make sure that we have our network segmented and our applications segmented, and we have proper control mechanisms between those segments. We need to design the network in a secure fashion to follow best practice standards and guidelines that are provided by various organizations to provide this proper level of security. Now, speaking from Cisco's perspective, obviously a lot of other vendors fall under this category as well, but there are a wide range of products and technologies that meet all of the modern security needs that the network has today. So we're going to talk about network security zoning in this chapter, or in this lesson. We'll talk about the modular network architecture design. We'll take a look at how Cisco next generation security products and features get integrated into this architecture and this principle of modern network security configuration. The first thing that we talk about from a high-level perspective is network security zoning. To restrict access between different parts of the network, Cisco identified, and this is not new to Cisco, it's obviously been something that lots of people have been doing for many, many years, is the concept of zoning, right? Zoning is used to mitigate risk, particularly mitigating the risk of having maybe one large flat network without access restrictions between those different network segments. So a zone is basically used to mitigate the risk of that open network. All right, and we do this by segmenting infrastructure services into logical groupings. Those infrastructure services might have the same communication security policies, the same security requirements, and so on. This is a design approach which is used to restrict communication to only the data flows that are defined by our security policy. These are all fancy ways of describing what network security is, right? Being able to define what data is supposed to flow from what point of the network to the other point of the network. Traditionally, it's always kind of been something that we do at a firewall, right? You have your inside interface, you have your outside interface, you have a DMZ interface. But in a modern network architecture, we're trying to extend this down to our infrastructure as well. All right? So the zones that we're creating, these zones are separated by zone interface points, ZIPs, ZIPs. The zone interface points provide a network interface between a zone, well, any zone, right? One zone versus the other zone. We implement this with our network security devices. And each zone interface point is created by using a component or a combination of different components in the network. Typical zones that you might see, a public zone, right? That's your external zone that's not under the control of the organization. The most common public zone is the internet, right? And then we have a public access zone. That's a zone that hosts maybe public-facing servers or public-facing services that the organization wants to provide for clients, and that would typically go into our DMZ. All right, those services get accessed from the public zone, so there has to be some sort of policy between the ZIP between this public zone and this public access zone. All right. Typical services could be things like an email proxy service, a web proxy service, reverse proxies, remote access, anything that you would essentially put into a DMZ. And then we have the restricted zone. That's your protected zone, your internal zone. That's where your most critical data resides, your most critical data services reside, and it's typically also the most secured zone and the one that should be limited. Now, these examples are just some of the common ones, but you can have lots and lots of additional zones in your modern network. You can have zones between departments, zones between business units, zones between functions like a data center zone and a host zone or a user zone and so on. You can get as granular as you like. To limit access between these zones, we have to have some sort of network security device to apply filtering or filtering rules so that the traffic is not allowed to flow from one zone to the other unless it's explicitly permitted by whatever policy you've applied to your ZIP, right? That zone interface pair. The security policy is used to control what traffic is allowed and what traffic is not. So this isn't rocket science. I mean, you guys have seen this concept before. It's not new, especially if you've dealt with firewalls and whatnot in the past. Now, Cisco has a modular network architecture that they use to further extend this concept, right? The modular network architecture allows us to provide a defense in depth approach by positioning different Cisco products or capabilities throughout the network, and then using those collaborative capabilities between those platforms to establish an enterprise-wide security posture. So we have a lot of different security technologies. They're going to be deployed at many different layers in our network where they can deliver whatever purpose or value that they're supposed to deliver in the network. So there are some basic principles that are applied to this Cisco modular network architecture. In fact, we see 7 of them listed here. So let's break them down. Defense in depth. Quite simply, it just means that we have, for enhanced visibility and control, lots of security technologies deployed in multiple layers, usually with a common strategy in mind and common administrative control to provide multiple layers of security, right? You go into a bank, you don't just have some old guy with a gun at the front door. You have multiple levels of security. That's defense in depth. The other principal concept of this modular network architecture is the fact that it's supposed to be modular and flexible, right? All the components that are described in this architecture are described by their functional roles. The overall network infrastructure gets divided into these functional modules like campus and data center and remote access and WAN edge and et cetera, and then those functional modules then get subdivided into even more granular functional layers or blocks like the access layer, edge distribution layer, core layer, et cetera. That modular design results in a whole bunch of flexibility, which allows us to do phased implementations when it comes to deploying security, new technologies, and whatnot, right? And that modularity also accelerates the adoption of new services that are being introduced into the network as well. Resiliency, of course, and availability, one of the critical components to any network architecture. And of course, we would say in our modular network architecture that we are going to minimize the possibility of downtime and failure by getting rid of or eliminating all of the single points of failure in the network. And that's a really, really important concept. We also talk about regulatory compliance, right? Not every business and not every entity is suspect or is that's not the right word, is subject, not suspect, is subject to this regulatory compliance, right? But because we have this modular architecture, if we do or if we are guided by these regulations and standards, the achievement of regulatory compliance is a little bit simpler because we can apply those compliance mechanisms to each component or each module of our infrastructure. All right? Of course, we want to be efficient, right? We have a life cycle of management and operations, and the design needs to be simple enough so that we can, troubleshoot and isolate problems quickly, which eventually reduces our overhead and our operational expenditures, right? We have to have auditable implementations. The network architecture design has to accommodate a bunch of tools that allow us to measure, verify the operations, the enforcement of our policies, our safeguards, etc. And if this was one large, flat, non-modular design, it would be very, very difficult to implement the tools and the mechanisms that are necessary to verify those operations. And then finally, global information sharing and collaboration. All right, what the heck does that mean? Well, it means that logging, event information, anything that's generated from the devices in the network needs to be centrally collected, We need to be able to do trending analysis. If we have some sort of a breach or vulnerability that's identified in the network, we need to do maybe event correlation on a particular event that occurred. And that's what's going to give us maximum visibility in the network. So by creating these modules, we can then apply standardized approaches to this management concept. So that's what they mean by global information sharing and collaboration. All right. Now the functional models, well, I guess not models, the functional components of this modular network architecture has separate modules that get divided into more granular functional layers and blocks. And then each one of those serves a specific role in the network. This is not new. We've seen this before, but not on such a scale that we see it now. We've always talked about, for years and years and years, the three-layer design approach to enterprise networks or campus networks, right? The access layer, the distribution layer, and the core layer. It's the same concept here, except we're expanding this design to include an entire enterprise rather than just a building or a campus or a specific network. So you're going to see references to to enterprise, right? The enterprise core, for example, we see that listed, where is it on this diagram? Right here, it's the smallest piece of the diagram, right? The enterprise core. This is the core infrastructure. It's actually the main part of the network, even though it's kind of infinitesimal on the diagram there. It's the main part of the network which connects all of the other modules together. It's our high-speed infrastructure, and the sole objective is to provide some sort of reliable and scalable layer 2 or most likely layer 3 transport across the network. Okay? Then we have our intranet data center. All right, where the heck is the intranet data center? We see internet edge, e-commerce. I guess it would be this block here, the data center block, right? What is the objective of this intranet data center block? Well, it's going to host all of the systems that are serving applications, storing significant volumes of data, etc. And it hosts our network infrastructure to support those applications, routers, switches, application accelerators, load balancers, etc., etc. But the key is, and it's different than, say, an extranet or an extranet data center, in that its sole purpose is to serve internal users and internal applications. Then we have our enterprise campus, this box right here. The enterprise campus provides network access to our users and devices. It could span, say, several floors. It could span several buildings. It just depends on how everything is physically connected. Okay? Now, there is actually a separate modular network architecture specifically for campus design. Remember, all of these modules, this is the high-level architecture, but all of these modules also have a lower-level architecture as well. So we can see, I don't know if this chapter is going to get into those details or not, these sub-models or modular designs that we have for each of these building blocks that we see in this particular modular network architecture, but you can go out to Cisco.com and search on Cisco Modular Network Architecture, and you can see all of their design models that they use. The next one we'll talk about is the Enterprise Internet Edge model, right? So that would be this guy right here. The Internet Edge is the equipment, the architecture, the components that provides connectivity to the Internet. This is different than remote access. This is different than say, extranet or branch connectivity and so on. It is literally the connection that allows us to get to the internet. It includes public services like a DMZ, corporate internet access, remote access VPN, and so on. The WAN edge, which we see right here, of course, based on its name, you can pretty much guess what it does, right? It provides or aggregates all the WAN links that allow us to connect our branch offices to our central site, right? So the object, the purpose of the WAN edge is to provide users at the branch access or give them access to all the same network services that we see at the main campus, right, at the central site. So this particular module allows branches and remote offices to securely communicate over a private WAN, like an MPLS VPN, etc., back to the main office. The next one we see, let's talk about enterprise branch. Well, you guys know what that is, right? The branch provides connectivity for users or devices at remote locations. Usually we have more than one LAN at those locations, but we don't have to. Sometimes they're very small offices, sometimes they're regional offices and so on, but obviously they need to be able to connect to corporate resources, so they're either going to connect to the private WAN or they're going to use some sort of internet connection. And we talked about a lot of the options that we had in the last chapter about, I mean, not the last chapter, but when, you know, our internet connectivity chapter where we talked about MPLS and DMVPN and so on. Then we have a management block. The management block combines out-of-band management and in-band management. Obviously, the objective here is to manage the, everything, right? Our control plane traffic, our management traffic, things like network time protocol might run over this in this module, SSH, SNMP, excuse me, syslog, etc. So, it makes logical sense, how this is broken down. But what we do then is we take these blocks, we take these modules, and we zoom into those modules. And this is kind of a representation of that, taking a look at kind of a deeper look into each of these modules. And we can start to see some of the security technologies, some of the products, some of the network communication components that we use in this approach to facilitate the different types of communication that have to occur in each of these modules, right? So we know that we're going to have the implementation of different security zones. Some of the zones and locations of the zones and so on will depend on what its function is. For example, the public zone is outside of the organization. It's going to be located in the enterprise internet edge module. The public access zone, it falls under the care and custody of the organization, and that's where we put all of our public services and secure access and whatnot. That might also be located in the internet edge zone or a module. Operations zone. Operations zones host things like support services for internal users, and that zone is usually located in the intranet data centers module. Our restricted zone, right, which we previously defined as the most critical zone because it's going to have our most critical data services. So obviously, naturally, we're going to try to limit access to only the needed traffic in this particular zone. All right. That also might be, by the way, located in the intranet data center module. Our management restricted zone. That provides the management for the network, and that might even be located in the intranet data center zone or module. All right. So if we look at this diagram and we start to look at the technology that's being implemented here, right? For secure network access, for example, We have wired and wireless access. We might have endpoints that are located in the enterprise campus or the enterprise branch. But the main objective of those particular functional modules is to provide secure network access to protect the endpoints from data loss, data theft, privacy invasions, whether it's malicious or not malicious. So security really has to be the focus on this for secure network access. All right? We might be incorporating VPN technologies to provide connectivity to the central site. So we're going to use network access like the internet or maybe even some ISP WAN services, which are not generally considered secure from the organization standpoint of view anyway. So VPN technologies have to be used to provide secure access to the central site. All right. Now those VPN technologies are mainly used at the WAN edge and at the enterprise branch. That's going to allow remote workers to connect to the organization's resources. The remote access VPN technologies are then used at the enterprise internet edge. Our firewalls, our IPSs, they're going to provide access control. And they'll provide access control between different points of the network. These are typically going to be used in the enterprise internet edge to control traffic that's flowing between different zones. Firewalls and IPSs are also used, by the way, in the intranet data center to control traffic between different network functional modules or different network functions based on applications and different application stacks that we might be running. Infrastructure protection, and by the way, this whole chapter is about all these components, right? We're going to break down all these components as we move through the rest of these lessons in this chapter here. Infrastructure protection, high-level security to the overall organizational network. But the network is only as secure as the infrastructure. We call that network foundation protection, right? Infrastructure has to be protected. Access to devices have to be limited to authorized devices and employees. The infrastructure protection has to be taken into consideration because if the network foundation is not secure, then it doesn't matter what other policies or procedures or equipment we might use in other parts of the network. And we'll need things like content and application security. And then lastly, we'll need some sort of network security management. All right. So what kind of platforms does Cisco provide for this network security? Well, they have next generation platforms. And by the way, that's just a term that Cisco used to define these enhanced platforms that include things like firepower, application visibility and control, AVC, et cetera, right? And it's good. I'm not going to suggest that it's not good. It's a lot of vendors have been doing this for a long time, and Cisco's now starting to integrate these tools and these technologies into their product lines as well. The ASA, for example, the next generation firewall, it of course does what it's always done, which is stateful firewalling and advanced clustering. That's kind of been a staple to the ASA platform. And of course, it also allows for remote access through the use of the Cisco AnyConnect client. But it also has AVC, application visibility and control. Actually, it supports nearly, over 3,000 application layer and risk-based controls specifically for applications. We have firepower, which is our next generation IPS. That's going to provide things like threat prevention and contextual awareness. Then we also have URL filtering. We can filter on hundreds of millions of URLs, and those URLs are categorized into different categories. We have discovery and protection against advanced malware and advanced threats as well. So the ASA can be deployed to do all these things. We have the 5506, which is kind of the smaller platform that offers up to maybe 250 megs of throughput, all the way up to the 5512 through the 5555, which you know, from the 5512 to the 5555, you're looking at a range of throughput of about 300 megabits per second to about 1.7, 1.8 gigabits per second, right? The high-end Cisco ASA products, like the 5585, the big daddy, right? That has different SSPs, and so we can offload a lot of the processing and a lot of the requirements, and that will actually give us up to 15 gigs of throughput per device. Obviously, that's not something you would deploy in a basic environment. This is something that we normally would want to deploy in an enterprise type environment or a data center type environment. All right. Firepower, which was an acquisition through Cisco, provides next generation IPS solution. Like I said, it does real-time contextual awareness. It gives you visibility across the entire stack from layer 1 all the way up to layer 7. Gives you intelligent security automation, reliable performance, blah, 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 right? Those are all the selling points to Firepower. We have to know them as a Cisco partner. So, and we get taught them just about every day, all right? The threat protection mechanisms. All right. With subscription licenses, I can integrate things like AMP, which is my advanced malware protection tool. That's a pretty cool tool. If you haven't had a chance to see something like AMP, I'm sure some of you have worked with it in the past, but it extends the threat detection capabilities down to the host layer, right? Allowing us to control our devices. So Firepower can be deployed as a separate physical appliance. It can be deployed, like, for example, the 8000 series appliance. Again, that's the big daddy, right? It's going to provide 15 gigabits of throughput with about 60 gigs of IPS throughput. The 7000 series, about 50 megabits a second of throughput to about 1.2 or 1.3 gig of throughput for IPS, and so on. We can also deploy next generation IPS as an appliance as well, or it can be part of our ASA with the integrated Firepower services. So lots and lots of options, and if you go through the CCNP security training, you learn about all of these tools from a hands-on perspective, from a technical perspective. So in this lesson, we talked about how we segment the network into different zones, how we apply zone zips, zone interface pairs, and we filter traffic on these interface points to limit the flows based on what we want to allow or disallow. We follow the architecture principles of the Cisco modular network architecture, and then we can use next generation products like the 5500 or Firepower, next generation IPS, and so on. So as we move through the rest of the lessons, in this case, we're going to take a look at all of these different technologies and kind of take a look at how they fit into our environment.